Hi everyone, it's Mrs. Gonzalez Clark again. We are continuing our journey on area and finding the area, mostly using fractions. So we have a very meaty problem today, and I'm actually going to break this problem up into maybe 2 to 3 videos because it is so much content within this problem. So we're going to start with the first part, and then my next video will continue with the other components of the problem. Okay, so I'm going to read the problem. Excuse me. Some wire is used to make 3 rectangles, A, B, and C. Rectangle B's dimensions are 3/5 centimeters larger than rectangle A's dimensions, and rectangle C's dimensions are 3/5 centimeters larger than rectangle B's dimensions. Rectangle A is 2 centimeters by 3 1/5 centimeter. So what we are focusing on is just this component for this video, because just finding the dimensions of these various rectangles might be a little daunting because there is a lot of information involved in order for us to even figure out what these dimensions are. So we are going to focus on this. Just putting a little crooked star there. Okay. All right. So we have some very important information that we need in order to create the rectangles and label them accordingly. So we have 3 triangles. We have triangle A. We have triangle, rectangle. Sorry about that. We have rectangle B, just putting their labels. And we have rectangle C. Okay. Perfect. Let me just slide this so it looks halfway even. Okay, perfect. So now we are going to draw a model of it, not precise, but just a representation to show the actual length and width of each of these rectangles. So the one thing that we do know is that we know the measurements of rectangle A, right? So rectangle A is 2 centimeters by 3 1/5 centimeters. So the length of rectangle A is 2 centimeters. Okay. And I don't like how I wrote that, so we're going to get rid of that. Pardon me. Okay. Just going to remake that line. And what I want to do is I'm just going to put it in as a text. So 2 centimeters. And then we have the width as 3 1/5 centimeter. Okay, perfect. So just so you can get a closer view, we were told in the problem that rectangle A is 2 centimeters by 3 1/5 centimeters. So 2 centimeters represents our length and 3 1/5 centimeters represents our width. So we have that covered. The problem gave us that information, which is very key. So it's information that we need, because if we don't have this information, we're not going to be able to figure out what the dimensions are of the remaining rectangles. So it's important that we have this. Okay, so let's go back to the problem. So rectangle A, perfect. We're good. So we are going to look at what it says about rectangle B. So rectangle B's dimensions are 3/5 centimeters larger than rectangle A's dimensions. So there's something very important they told us there. We know that rectangle B is definitely going to be a bigger rectangle. So I'll try to make one a little bigger. Okay, that looks a little bigger. Okay, so we know that rectangle B's dimensions are 3/5 larger than rectangles A. So that means rectangle B's length is 3/5 bigger, larger than rectangle A's. So if we take 2 and we add 3/5 to it, that means that rectangle B's length is 2 3/5 centimeters long. So 2 3/5 centimeters long. Okay, so because it said that it is that rectangle B sides are 3/5 larger than the dimensions of rectangle A. Okay, so now we need to find out the width. So rectangle A's was 3 1/5, and rectangle B's is 3/5 larger than this width. So 3 1/5 plus 3/5 gives us 3 4/5. So that means rectangle B's length is 3 4/5 centimeters. Okay, awesome. So we were able to take the information that was here, told us that rectangle B's sides, its dimensions, are 3/5 more, 3/5 centimeters larger than rectangle A's. So 2 added to that 3/5 gives us 2 3/5, and 3 1/5 plus those 3/5 gives us 3 4/5. So now let's do rectangle C. So I'm gonna draw rectangle C. Remember, it's just representation. It's not perfectly made. But let's read about rectangle C. So rectangle C's dimensions are 3/5 centimeters larger than rectangle B's. So that tells me that rectangle C is going to be bigger than rectangle B. So let me draw a rectangle that's a little taller and a little longer. That's really quick. Okay, not too bad. Not terrible. Okay, so now we have rectangle C. So rectangle C is 3/5 centimeters larger than rectangle B's length and rectangle B's width. So if we took 2 3/5 and we added 3/5 to it, that would give us 3 1/5. So the length of rectangle C is 3 1/5. And all I did was take the 2 3/5 and add 3/5 to it, because remember, this is 3/5 larger. I keep doing that. So 3 Okay, they did it again. 3 and okay. This is so weird. Okay. 3 and 1/5 centimeters. That's the length of rectangle C. Now we need to do, just want to fix this up. Sorry about that. There we go. Okay. Now we need to see the width of rectangle C. So the width of rectangle C, again, has to be 3/5 bigger than this. So 3 and 4/5 plus 3/5 gives us 4 and 2/5. So I'm just going to type that here, but I'm going to move it. Don't think that that's where I'm labeling it. So it's 4 2/5 centimeters. Okay, and I'm just going to slide that right over here because that represents our width. So we were able to use the information that was given to us in this problem in order to decide and see what is the actual measurement of each of these three figures' lengths and widths. And we were able to figure that out all based off of the measurements of rectangle A. So in our next video, we are going to dig a little deeper into those dimensions and find the areas of all of these three rectangles.